Hello, class. This is a short introduction to gas behavior. I'm primarily going to focus on some gases vocabulary for this lesson. And then at the end of the lesson, there will be some additional videos that you can watch that are some demonstrations involving gas behavior. One of them is a soda can demo. The other one is on something called the Cartesian diver. And we may have a few more demos coming shortly as well. Okay, so the first vocabulary term is temperature. As we go through, just make sure you're getting these definitions down in your note sheet. So temperature is the measure of the average kinetic energy or the speed of an object. A lot of people associate temperature with heat, but it's only an association when it comes to chemistry. We primarily view it as a measure of speed and energy. Since we're talking temperature, we need to know about the Kelvin scale. Primarily, we've used Celsius at other points in the year in chemistry. The Kelvin scale is a temperature scale based on molecular motion. Unlike the Celsius scale, which is based on the boiling point and freezing point of water, the Kelvin scale is directly proportional to the average kinetic energy of the particles of the substance. To find the Kelvin temperature, all you have to do is add 273 to the Celsius temperature. Technically, it's 273.15, but we'll just leave it at 273. When I mean it's directly proportional, if you have a sample, for example, at 200 Kelvin, it is twice the energy or twice the average kinetic energy of a sample that is at 100 Kelvin. So it is proportional. Whereas if you were to double something on a Celsius scale, it is not going to be directly proportional. Another important concept related to temperature is the idea of absolute zero. Absolute zero is the temperature 0 Kelvin. It is a theoretical temperature. We have never been able to reach it truly, but we have used some gas behavior data, and we've been able to extrapolate that data back to the point where that linear trend hits the zero on the y-axis, and this is the temperature where all motion is said to have stopped. So everything is perfectly frozen at that particular point in time. There's no motion of particles there. Volume we've talked about before. We know volume is the amount of space that something takes up. In relation to gas particles, volume can mean two things. If it's in a flexible container, the volume of the gas can change because we know gases can take up the space of the container they're in. If that container is flexible and the gas expands, then the container will meet the volume of the gas where it's at. If it's a rigid container, the volume of the gas is fixed. For pressure, pressure is the amount of force applied over a given area on a surface, so it's the force per unit area, but we're primarily talking about it in terms of gas pressure in this unit, which is due to collisions of gas particles with the walls of a container. The gas pressure can be affected by both the speed of the particles and the number of collisions the gas particles have with the walls of the container. Compressibility is just the idea that matter can be squeezed or made to be put closer together in a smaller space. So it's a measure of how much a given volume decreases when placed under pressure. Another idea that we're going to need is standard temperature and pressure. This will be important when it comes to unit conversions. The standard temperature is 0 degrees Celsius, which is the freezing point of water, or 273 degrees Kelvin. And then the pressure is 1 atmosphere of pressure, or 1 atm. There are a couple other pressure units we're going to look at that are equal to them, but we'll cover those in a later lesson. And the last vocabulary word we have is density. This is the mass of an object divided by its volume. This will be really important when looking at different sized gases. Larger gases that take up the same amount of volume are said to be more dense than other gases, so we need to pay attention to those densities later on. Density will also be important for one of the demos that we look at later on in this lesson. Okay, that is all for the vocabulary. Again, in our at the end of this page, there's some demos for you to watch, and please explain to the best of your ability.